All right. Hello, everyone, for today's instance of obo-academy. Today, we are going to talk about how to generate SPARQL queries with, for example, tools like ChatGPT and others. And I want to say that we've been talking a lot about using LLMs and fully automating our workflows and everything. But the truth is, in practice, like if you would ask me, like what do I do most of the time and how do I leverage these technologies? I personally still use this pattern that we would talk about here a lot. So like I want to query the ontology, I want to generate a report, for example, I even want to update the ontology, all of these things. And I go to ChatGPT, I ask it, how can I go and write me a SPARQL query for doing this, which I previously all did by hand. Maybe I'm losing a few brain cells now because I'm offloading some of the kind of hard thinking to ChatGPT. But the truth is that I've become much more also productive when it comes to these things. And I think for you and most of the people here that are like more on the curation front, this will also help you to become a little bit less dependent on us technical people for generating, your tables with raw information from the ontology and your and the various other things you want to do with SPARQL, even generating QC queries in the end. So that's why I think I'm very particularly happy that Trish Wetzel did volunteer today to help us a little bit on the first steps to generate SPARQL queries using large language models. And like always, please feel free to use the chat for any questions. I will make a kind of like judgment of whether we should just interrupt Trish while she's talking to clarify some stuff. Or whether I would, wait for like a more natural break later for asking the question. But as always, we try to be interactive, and I'm going to follow this tutorial. So I'm going to do what Trish is saying, and I would encourage you, as many of you as you can, to do the same thing. Yeah. So, Trish, with that, take it away, and thanks for doing this.
Yeah, sure thing. Yeah, thanks so much for that introduction. So as Nico mentioned, so today I'm going to be talking about using large language models or LLMs to help us generate SPARQL queries. And this tutorial material, I've tested this out with ChatGPT 4.0, 5, and Gemini 2.5 Pro. And this material is primarily intended to be used from a chat interface. As you'll see the way we're prompting things as we get through down to the material. And just one note, and while I've gone through a number of iterations through this material and trying to get the responses as consistent as possible, LLMs themselves are inherently not deterministic. So the response that I get may be different from what you get. And if you wind up getting something different and it's just really not working, then just raise a hand, make a comment, and then we can iterate through some other ways how you can work through those issues and get a working query. So the queries that are generated, we'll be testing those out. There's a few tools that you can use to test these out, and I've just mentioned a couple of them here. So one is the YASGUI, and I hope that's the way that's pronounced. But this web interface, which provides, access to the ubergraph endpoint. Or alternatively, you could also use the robot tool and the query functionality as well if you want to run this from the command line to test the queries. And so before we get into the prompting, I just want to do a little bit of a SPARQL refresher just so that we're all have the same baseline of some basic information. So in general, SPARQL is a language that we can use to query ontologies and pull information out of those ontologies or update content in the ontology itself. These query patterns consist of triples. Presumably everybody here has worked with ontologies and very familiar with these triple patterns of the subject, predicate, and object. So for example, we have here, so this entity is saying that this entity is an OWL class. There are patterns that can be format or pattern formats such as conjunctions. And in this example here, In order to return the entity, all of the triples need to be true to return the entity. So this is asking for all the subclasses of Mondo disease, as well as returning their label. And in particular with the obo foundry ontologies, this is safe because they all have a label. If you're working with some other ontology where for some reason it might not have a label, you might want to use an optional pattern that I'll mention in a moment. There are also disjunctions, and in this case, with the disjunction, we can use this keyword union. And here with the disjunction, we want to have the entity match one or the other of these patterns, or if the entity matches one of the other of these patterns, it will be returned by the query. And again, as I mentioned, there are also optional, you can also use the optional keyword. And what this helps us do is be able to return all the entities that match the given criteria. And for any of those that optionally have this other information, for example, such as a definition, that will also be returned. So for example, and I can show this later, if we query, for example, for Mondo without and don't make this optional, then we don't necessarily get back all the subclasses. And again, so SPARQL can be used to query all kinds of information from the ontology, from its class hierarchies to annotation properties and labels and definitions, xrefs, and dig into the logical class definitions as well. So a few of the basic SPARQL operations. So there are select queries, and this is the type of query that in this tutorial we'll focus on. And this is basically to retrieve specific information from the ontology itself. There are also operations that we can do, such as insert, to add information to the ontology, as well as delete, removing information from the ontology. There are various modifiers, and so if we want our SPARQL results modified in certain ways, so we can use an order by statement, so we can sort the results based on some given field. We can limit the number of results returned. We can use, for example, distinct if we want to remove duplicate query results. And then we can also use some of these other modifiers, such there's a group concat and group by and having to aggregate data. And I have some examples later that we'll get into with using these, as well as filter. And one of the most common things, at least in the queries that I've been writing for Mondo, is using filter to filter out obsolete terms. But you can also use filters, say, for example, to keep only terms with the Mondo identifier, for example. And also, just to note, this tutorial material is primarily focused on Mondo, but the concepts are throughout this are applicable to, obviously, to other ontologies. So just to go over a bit of what a SPARQL query looks like. So at the top, we'll have our prefix declarations that will declare the namespaces that we'll be using. So in essence, I kind of think of these as a kind of a shortcut to not have to use the whole IRI here. Then we'll have the select clause, and then the where clause, where this will list the different triple patterns that we want the query to match. And then you can add in various filters. And then finally, at the end of that, then you'll have your, you can add limit or, some of these other pieces of information at the end here. And the limit is limiting the results to 10. And again, I would suggest for the, in these queries that you do use a limit, just to try and speed up the responses from YaSCOI. And for more detailed information about SPARQL, there's a lot out there on the web itself. There's also a lot of content here within the obo-academy material. And here's one of these links that's a good entry point into getting more information. That is the basic SPARQL for obo engineers. And as I mentioned earlier, there's a few tools that can be used to run these SPARQL queries, one of which is Robot. And again, for today, we'll be using this web interface as the entry point into the Uber graph. And also, just to reiterate a few things that Nico had mentioned, so that why and how is SPARQL important? So SPARQL can be used to create custom reports, in particular in Mondo and probably many other projects as well. It's used to generate various statistics. So, for example, how many disease classes are in Mondo, how many Mondo classes have a gene association. If you go to the Mondo website, you can see there's a stats section here where after each release, these stats are updated and presented on this website. Also for ontology quality control and modeling validation, I think Mondo has about 70 different QC SPARQL queries that are run on each PR. So that's very handy to make sure that everything is following the various rules and modeling patterns for Mondo, as well as on the ontology and engineering side. Using insert and update queries is very useful. These are used in many of the pipelines, and the Mondo pipelines to modify and insert information from the various ontologies that are being integrated into Mondo. And then just a little bit about what are large language models, just again to provide a bit of a baseline here, although most likely everybody at this point has heard and has some familiarity with these. So large language models or LLMs are basically just AI systems trained on huge amounts of text. They can understand and generate text and code. And a few examples of these are ChatGPT, Claude, and Gemini. And what's really nice about these is that we can interact with these using natural language. While there are APIs to work with these, we can still formulate our question in natural language. And just one caveat, we do need to be aware that the LLMs can make mistakes or hallucinate information, so it's always good to review and validate the results before using them further in your work. And again, just a brief mention of why large language models matter for querying ontologies. So when writing SPARQL, or going back to this, so natural language is intuitive for humans, but it's not machine readable. And the SPARQL queries are precise, but they can be hard to learn and they can be time consuming to write. The LLMs can help bridge this gap by translating our natural language questions into a SPARQL query, and therefore we can lower the barrier of entry into writing SPARQL queries by, at a minimum, getting this first pass at the SPARQL query, even though we may need to iterate over that further to actually get the correct query. It really opens this up to anyone on this call should be able to follow this material and be able to generate some SPARQL queries. And a few comments on prompting LLMs for SPARQL queries. So you want to try and be as specific as possible and state your question clearly. You want to include what properties to return, include the modifiers or any constraints that you want your query to include. Then you also want to, if needed, you can also share an example of an existing query and then ask the LLM to extend that to include additional constraints. The LLMs are also handy for being able to, if you have a SPARQL query and you're not sure what that means, say, for example, you've run into a QC error and it's not clear what has caused that, you can also just paste in the SPARQL query and ask the LLM for what information or for what the SPARQL query is doing, so that it can help you return point out the error that might be in the ontology of your edit. And again, always review the query, test, and iterate. And we'll start getting into the prompting.
Trish, 1 second.
Sure.
No question, but can you just increase the font size a little bit from your browser. I'm thinking a little bit about the users that will follow this tutorial on YouTube later, and I think that the fonts, like if you can hit Command plus or String plus, I don't know, just to make it, yeah, I like that. Great, thank you.
Okay, is this good?
Yeah.
Okay. Okay. So now we're down to so we're gonna include a bit of prompt setup here for our chat-based LLM. And so what I found in iterating through these various queries, that when I was using the chat interface and as I was asking at different times to refine the query, when I moved over to another chat interface, a lot of the information that I had already included or refined in one chat interface was, was being included in the memory of that. And so what I did was to set up basically a prompt context file, which I'll show in a moment here. So to help make the queries more often return the correct result from the first prompt, as well as help guide the LLM initially, and also in some of these more difficult or more axiomized pieces of information to return from the query. So again, this is the prompt setup, and so when we start, to start, we'll first take this file and just copy this into the chat interface. So this includes some information. So we're asking the LLM to act as an ontology engineer with expert knowledge of SPARQL, and again, in this case, since the material is focused on Mondo, with knowledge of Mondo. These queries will be run in YaskGUI, but they should also be formatted to run in Robot. I've also found that in some of the chats that the responses I was getting would work in YaskGUI, but there were some constructs that were not compatible with Robot, and I would have to go back and iterate. And this line just helps direct the LLM to provide information that will run in either system. Also, this is just a note for with respect to using ubergraph, which I believe by default returns all subclasses. We just want to say that we want to specifically or explicitly use this when we get the subclasses. We'll be excluding obsolete terms using this pattern. For labels, we'll be using REFS label. Another area where I found that I was having a lot of hallucinations happening were with the prefixes. So I set up the common prefixes in this file to state them in the beginning versus having to continually go back with the LLM to get it to use the right prefix. So we have our core RDFL prefixes, a prefix from Mondo, and then some other common obo namespaces. And then also adding in some additional information of how some of these other features are modeled in the ontology, so that the LLM can return the right query. So for synonyms, database cross references, for example, and then also in particular for gene associations as well. And just a bit about the output. So this is indicating, so I want the query returned to me as in a code block that I can copy paste. Use distinct when appropriate. In this case, convert IRIs to the label, or sorry, convert IRIs to a query. And also that I'm going to be providing the prompts in plain English, but respond with only the SPARQL query and just a one-line explanation if needed. I also added this in because at times the LLMs it would return the query, but then just a whole load of text explaining the query as well, and then just a few other defaults. So we can just copy this here, and add this in here. So if we just paste that in. Okay, so now we have our basic setting for how we would like the LLM to respond. So we'll start off. I try to include a few basic categories of queries to show some examples how to pull out different pieces of information. And so we'll go from more simple or straightforward information, and then towards the end get into a few more complex bits there. So start off, there are so first of all, we'll start with counting all the subclasses in Mondo. And here, so the suggested prompt is to write a SPARQL query that counts the number of classes in the Mondo ontology that are subclasses of Mondo, and I provided the query and then the name of that. And I also included these prompt breakdown sections just to highlight some of the information that is useful to include within your prompt itself. So the type of query here is going to be a count query. Our target class that we're looking at are all the subclasses of Mondo disease, and just the ontology scope is Mondo itself. So we'll just copy this and drop this in the chat. And it pretty quickly returns back a query and just one quick explanation of what's happening here. We can see it's returning back our prefixes that we need, and we want to count the distinct number of classes that are subclasses of Mondo disease. And again, so we're counting only the Mondo classes, and we're filtering out obsolete terms. So we can just then paste that over into YaSGUI, and we can see that it returns the number here. And for anyone who's on the call who's very familiar with Mondo may look at that number and think that doesn't look correct for the November release, and you would be correct, and that is because YaSGUI currently still has the October release of Mondo loaded. So are there any questions on the information so far?
There's one question. Should you add all of the kind of important information for your query? Like, for example, if you add should you add how are the taxons handled in Mondo if you want to have a query that includes taxon, and how are any individual properties used that we're using in Mondo in order to get a correct response for queries that need that construct basically as a restriction. So is there a sense of like, do you have to be very explicit, or can you just give it a shot basically to see whether it comes up with the right answer?
Yeah, so it can, yeah, exactly. So that's a great question. So yeah, you can certainly just ask the LLM and see what it gives you as you if you need to, and most likely perhaps in those cases one would need to iterate through you to direct the query to get to the direct the LLM to get to the correct query. Then again, you might want to kind of keep this context file so that when you run future queries, or if you start a new chat session or something like that, that would or share amongst your team members, that if they run that query, then that particular construct is already in the context file. So again, a lot of the context that I've put in here for the prompt setup were things that I had iterated through over various times, and realized I in order to get these to be as reproducible as possible, I needed to state those ahead of time. But again, so you can certainly you don't need to have everything in there, but as you find certain things where the LLM is stumbling or having problems, this is sort of like a cheat sheet or just helps the LLM get directed from the start.
And if I may add to that a little bit, I think that that one, obviously exactly as how Trish says it, there's you have to try it a bit to see whether it's necessary to add this to the instructions. And it's also a really good idea, to kind of give the instructions and collect them somewhere so that you can just paste them at the beginning of your session. But I also think, depending on how widely spread a concept is used across Obo Foundry ontologies, you can always think, what did the LLM use for learning? And did the LLM have a chance to encounter many examples, for example, of SPARQL queries in the Mondo repo that when it was learning, because it was certainly using the Mondo repo for learning its knowledge about SPARQL, did it have a chance to get those from somewhere? And that gives you a higher confidence that you might not have to add that detail. And on the other hand, if there's a new pattern that you just introduced and you know that there's no way that the LLM can know about this, then you would have to certainly tell the LLM how this pattern works so that it can generate the query correctly.
Exactly. Okay, so now we'll go and look at an example of filtering, and which though somewhat came up in the previous query, but here we will count all the exact synonyms in Mondo and exclude obsolete classes. So here again, just write a SPARQL query to count all the exact synonyms. In this case, I did include the property here. And as we just discussed, if you just want to leave it at exact synonyms and see what it returns, that's obviously perfectly fine. If that's not returning the information that not using the right property, then it can be helpful to include that here, so that the LLM is directed as to what property to use to start with. So we'll just try this one. And we get our query back. So we're counting the exact synonyms. Oh, interesting. Let me see. So I also put an example of okay, yeah. I also put an example of a working SPARQL query in case your prompt is not returning either a query that's working or returning results as expected. And another thing then you can also do if there's issues with the prompts, you can also go back and in this case with this tutorial here, go back and copy paste the working query and then ask the LLM, what's the difference between what you provided earlier in this one, or what else should I have included in the prompt to have this query generated. So we'll go back and test this one. It takes a little bit of time to run here. And so here we get our count of exact synonyms. Let's see. So also now we can jump into retrieving back labels and other annotations. So here, this is an example to get the Mondo terms. We'll get the query and the label, and again, exclude obsolete terms. So in this case, so I think I may have written some of the examples before I set up the prompt context. So there's a little bit of duplication here. So, but again, when I wrote the prompt itself, I specified the various properties here with the prompt context that might not be needed. So here we're going to get the human readable labels using RDFS label, and again, including the information that we want returned, and we'll limit this to 20 results, and again, exclude obsolete classes. And again, we get our query, and yeah, I think that looks good. Let's test that and see what it looks like. Again, sometimes these queries take a little bit of time to run. Okay, so great. So now we're getting our Mondo query and the label for those terms. And we can start to dig into how we would query for synonyms and database cross-references. So this is starting to dig in a little bit deeper. So we're going to get a count of all of the Mondo classes that have an exact synonym, and that is an exact synonym where the provenance is from Orphanet. And so here we're going to write the query, again, getting our exact synonyms, exclude obsolete classes, and we want to say that it's annotated with the database reference using the obo-now has dbxref. And again, this in particular, this was one that without this information, I was getting some trouble having the LLM return the correct information, and this is why I added this into that prompt setup context file. But I'm also indicating that it should use this axiom annotation pattern to connect the synonym to its provenance. So let's give this one a try. Okay, so that looks pretty good. And then we'll test this one out. Oh, yeah, Nico.
Yeah, so I noticed that when I followed along for the last three, I think that the query looked a little bit different than the one that you came up with. And I'm wondering, this difference could be because I guess ChatGPT has maybe some sort of internal understanding that is beyond your conversation about some of your preferences. So, for example, I got the the replacement pattern for like the turning an Perl into a Mondo query. It was put into the select statement, which I have never seen before. But actually,
Oh,
if you do it
really?
like that, you say, yeah, it's not, I don't think it's a problem. It's actually interesting, like to just see it. It's just something that you maybe you save a bind in the where clause, but it's yours is actually a little bit more nice and readable. So I guess if you wanted to have that replacement pattern for the Mondo queries, you could also go to your context and add something like uh, for all my queries, I want Mondo IDs to be returned as queries. Use this pattern to do so, and just to be sure that this is always going to happen like that, and not that it, like just creates different variants of how to, turn the Perl into a query string.
Yeah, exactly, exactly. So I think I do have this pattern, but I don't in the context file, but I don't actually say where in the query that it should be added. But yeah, no, that's so yeah, that's interesting. So yeah, I was gonna start a new chat, but I realized there's yeah, my chat GPT at this point does have some additional global memory of my various chats. So that yeah, so again, so folks who are trying this may be getting different results. But again, yeah, that's in part why I try to collect all those up when I tested with a different chat interface. But yeah, so in the prompt setup itself, there's um yeah, so it's the filter here, but not the yeah, I thought oh no, maybe oh actually okay, so yeah, maybe I don't actually have that in there. But yeah, so that would be another thing that could be added. So I mean if if people find it useful, for given ontology projects to be using LLMs to generate SPARQL queries, just like in the various other AI efforts where a lot of uh, the AI for curation work that's being done with a lot of files are being collected. It might be useful to, again, keep one of these files in your repo that folks can contribute to. Um, okay, so which one were we just on? Exact synonyms. I think we're on the synonyms and cross references here. So then we'll just jump down into, I may be skipping through a few of these just for time's sake here. So for conjunctions, again, this is where we want the results need to match all of the triple patterns. And so here, this is to write a query to get the label and return return the Mondo query and label and synonym. Actually, I will run this one because there are some things later I want to show with some other options. Interesting. It needs to think a bit harder about this one. Okay, and we can test out this. So again, we're getting the query, the label, and the synonym, and it needs to match all of these patterns. And we're limiting it to non-obsolete Mondo classes. And in this case, you can see so that for each exact synonym for the Mondo class, we're getting a new line in the results, and that may or may not be the format of the results that we want. And I can get into an example where there's at least an example in the tutorial that will show how we can aggregate or pivot this information so that we can get this as a list and not have multiple lines per class. So also, again, so disjunctions where we want the result to match one or another triple pattern. And so here is to get the Mondo terms, the synonyms, and the synonym type. For either exact synonyms or related synonyms. And so I'll put this in run that prompt and why that's running. So I picked this as an example of a disjunction, and this is a little bit of a contrived example, but just to try and make the idea of this of this union a little more clear. Another way, as Nico had pointed out in an earlier conversation, that is probably a preferred way, in particular for querying out synonyms, is to use there's another construct we could use using values to pull this out, but this is just for example purposes here. And so we can run this query. And here I increase the limit just so we can get down to some examples where we start to find terms that have both exact and related synonyms. Okay. So now this is pretty similar to the results of the previous query, but now we have an additional column which says what the synonym type is. And if we scroll down, we can see that, yes, here it is. So Mondo, this Mondo has a related synonym. And again, if we check for this, for example, in Protege, we can scroll down a bit. We can confirm that that this term does have this related synonym. And then we'll take a look at using optional patterns. So again, writing a query to get all the Mondo terms and the definition, the text definition, if such a definition exists, So again, here I included the property just to try and make it more specific from the start. Again, if you don't know this information to start with, you can always just try it and see what the LLM returns. But if you're finding that it's not able to bring back the correct, if it's bringing back a property name definition versus this predicate, then you can just include that in the prompt itself. So we have this. And again here, so again, the definition is optional. And we'll see, this might take a little bit of time to run. Okay.
By the way, this is nothing that you can solve with ChatGPT so easy. I guess you could put it in the context file if you wanted to, but if you're using a lot Yasui for your queries, also for saving the Renzi servers a little bit of processor time, it helps to add another clause in the query, which is RDFS is defined by mondo.owl as part of the first part, where you say class A owl class, and then you say RDFS is defined by mondo.owl, so that it doesn't try to match your triples in the entire triple store, which is enormous, and instead focuses on like a handful of triples that are in the Mondo ontology instead.
Oh, okay. Yeah, thanks. Yeah, that's a great addition, and yeah, to include in here. So you can see here with again, jumping back to the example, we are looking for Mondo terms and their label and the definition that exists. So here, regardless of whether the class had a definition or not, we can get this returned. If we commented this out and made this required, then then we would start losing these. The classes without the definitions would not be returned from this query. And so now we'll get into a bit of grouping and aggregation. Here, this one, I think I need to update this description just a little bit. So this should be getting Mondo classes, their synonym count, and a list of all their synonyms. So again, non-obsolete Mondo classes, their exact synonyms. So I'm indicating to use count to calculate how many synonyms there are for each class. Again, this is just through some things through iteration that I found was helpful to include. And this was this keyword, this group concat. To list all those synonyms in a single field. And so we'll write this. And it looks like something else popped up in the chat. Is there another question?
No, I will tell you.
Okay, and then we'll test this. So you can see here, so this is using this this keyword group concat to bring together all of the synonyms. So here, as opposed to earlier, oops, let me try and fix that spacing a little bit. So here, as opposed to earlier, so before we were getting one line per synonym, and now we're only getting one result line per class, and we've pivoted each individual synonym into a synonym list itself, and then we're getting the count of how many synonyms exist for that particular Mondo class. And in this case, when we're doing this kind of aggregation, we also need to include the query. You want to make sure that this is going back more SPARQL than prompting, but that it includes this group by clause to include the other fields that are not part of this group concat statement here. And let's see, I think we're just about okay on time. So then we'll dive into again a bit continuing a bit more detailed type of query. So here we want to get all the mono terms, the exact synonym, and the provenance for these synonyms. And again, if we take a look back at Mondo itself, so we can see that the provenance is represented as database cross-reference, and there can be more than one source of provenance for synonyms. So again, we're going to want to use the aggregation to provide this as a list. So here is saying for each synonym, also retrieve a list of the database cross-references. So we can test out this query.
So can I ask one question from the chat and also make a comment about that question as well?
Yeah, sure, go for it.
So, and I agree a bit with the question, and I agree also that it might be an overspecification on the prompt side. So the question is basically, given this kind of aggregation query that you put before, not this one, you've actually included some of the more technical jargon around SPARQL into the query, like saying use group concat or use count, which is something that maybe some people might not be fully aware of. Let's say that these exist or how they're called or something like that. So, do you think this is necessary, strictly speaking, or is your feeling that it could have been just described in the sense of like aggregate the stuff and just see that the chat program would come up with this?
Yeah, sure. So a lot of these things, so as I've iterated through these prompts many times, a lot of these things, and I realize and then looking back at it, where again some of these things that again someone new to SPARQL is probably not going to know these specific pieces of information. I've included in the query here just to try for the tutorial purpose to try and make this as reproducible as possible. But again, most likely someone is going to come to this and not include that information, and then we'll need to then may need to iterate through um, and iterate through with the LLM to be able to uh, get that have it use those specific SPARQL keywords if it's not coming up with it by itself. Or again, additionally, these can also be things that can be put in that initial like prompt setup context. So it really just varies. At the end, I wound up including them in here again just to trying to get things as reproducible as possible.
And I would add to that so while probably it's probably going to come up with a good result, even if you don't include the specific function, there is a little bit sometimes a point to know a little bit about the query language that you're using, because I've written, I don't know, like 10,000 queries with group concat in them, and up until now, I'm not certain whether I would be able to write this like horrendously ugly construct or just from my head and remember it. So I do know that this is, so after many queries, that this is what we need in order to aggregate across data, and it's not like such a technical thing if you use it as often as I do. then it really still helps that the tool will format this stuff correctly in the way that I intend, and it's so it's this query looks technical, this prompt, and I think it might not be necessary to be so technical, but I think that just enough knowledge about SPARQL such that you have seen or know that there is such a thing like group concat will definitely help with making your queries more deterministic, as Trish said. So yeah, that's I believe in any case the case here.
Okay. Yeah, and that's why I included in addition the little bit of the SPARQL refresher, and I'll make sure that in particular that I get this modifier or get this keyword back in that section as well, because that was the point to include the particular keywords that were used through the queries in the tutorial itself. Let's see, so I think we're here. Let's see if, oh, perfect. Okay. So this has now run. And again, here we're not aggregating on the synonyms itself. So we're still getting one row per class per synonym, but we are aggregating on the provenance here. So we can see there's the different sources for these synonyms is included as a list. And let's see, and I think this might, yeah, this is the last. I think I'll just pass on this query. We can, again, it's just as a discussion before, this does have a bit more information. Again, you can certainly try and this is a query to get gene associations from Mondo. There are a number of different gene association properties in Mondo. And in this case, the intent here was to get the gene associations that were based on a germline mutation. So again, you can leave out some of these details, like stating what the RO property is, and see what the query returns. It may actually return all the RO properties and things like that. So again, it's just a matter of again, for the tutorial, I try to keep this a little closer to what could be reproducible. But this can also just be written without some of this information, and then depending on the information that you want to get back, then you can just iterate with the LLM or modify the query to what you're interested in. And then just to sum up, so again, a few best practices or things to try and help get as correct and potentially deterministic response as possible. So again, so for me, and it had been very helpful to provide the context for these different prompts. And again, trying to be as specific as possible and state the question clearly. As needed, include examples in the prompt. So some of these more other axiomized annotations and things like that, these more complicated constructs in OWL itself may be useful to, and in particular, like trying to query out information that's within a logical definition, providing that as an example to the LLM, in particular, going to the OWL file itself, and you can just copy paste the entire class statement, so you can find your term of interest and just paste in the entire. Even though it's a bit long, the context window is certainly large enough to handle this. So just paste in the entire thing and help better direct the LLM to pulling out the information or writing the query for the information that you want to retrieve. As you're able to try and use the real name of the property, versus something generic. And again, so in some cases, I mean, for some very simple things, you might be able to use just the obo stanza as an example, but again, for some more complicated modeling, it's best to just go back and find the OWL, then an OWL version of your ontology and provide that as an example. State the information to be returned, include the modifiers that you're interested in. Again, you can share an example query and then just ask the LLM to extend this. So again, like getting the LLM to get the basics and then get it to add in more complicated information about the construct to be queried out from the ontology. Again, you can always ask the LLM for examples or explanations of an explanation of the query, and always review, test, and iterate as needed. And just again, just mention a few of the pitfalls and limitations here. So again, just keep in mind LLMs can hallucinate. It's not deterministic, so what might look like it's working might be wrong or inefficient, as we've seen a few different responses, as Nico mentioned, some different results. Always validate the query. As need to iterate with the LLM. Provide feedback. And also, as we discussed earlier, so there might be some issues with schema or ontology drift, or say, for example, a new ontology or new construct in ontology that the model has not been trained on. In that case, again, it's useful to provide that information upfront to the LLM as an example. So that's all for today. Are there any other questions to go through?
Yeah, there was an interesting discussion coming up of whether you could, why not use, for example, something like Claude Code instead, where you could leave all this stuff that you've gathered together as like a skill file behind and kind of like let it generate actually the files on disk while you're at it, rather than using the chat program as well.
Yeah, sure. So that's certainly another potentially valid option. This material was generated actually a few months ago, and I think the Claude skills are fairly newer. At least they're certainly I've only come across them in the last few weeks or so, but that's certainly another option. There may be some different things with the way the memory with the LLM is handled in that case. That might provide a little bit of a difference, but that's also certainly, certainly an option and worth trying.
Chris, this was excellent. Thank you very, very much for this tutorial. There are some follow-up suggestions by Chris on what you could do as a follow-up on the work that you've already done in the chat. So maybe, I don't know whether the chat is shared as well afterwards, or whether you just want to copy paste it before you leave. But this was really, really useful, helpful, and fun. Hopefully some of you, only a few of you gave me a thumbs up that you actually followed along. But I hope that some of you actually tried some of the queries as well. I particularly liked, and I never did this before, the prompt setting in the beginning. So setting myself a good context. So thanks for this this kind of like thinking pattern as well. And yeah, hopefully see you all next time for a continuation of Chris Tabone's introduction into using Claude Code for doing curation as well. So you can get the information as usual on our obo-academy seminar websites. Thank you very much. That's it. See you all.